by Addis Ababa City Administration Education Bureau in collaboration with Addis Media Network. And I am Bzuna Makonnen. Today's lesson topic is area and circumference of a circle. Area and circumference. Circumference of a circle. Students, after this lesson, you are expected to calculate area of a given circle and circumference of a circle. So before directly proceeding to the lesson, let's see some terminologies that we will use to calculate area and perimeter of a circle. So let's proceed to that. First, let's see the definition of a circle. Circle. Circle is a set of points in a plane that are at equal distance from a fixed point called center of a circle. So here, circle is a set of points in a plane that are at equal distance from a fixed point called center of a circle. A circle. So here, if you have this fixed point, set of points at equal distance from such a fixed point, just you will have such a circle. So the set of points from a fixed point that are at equal distance from a fixed point is called a circle. So here, the fixed distance from the center to any point on a circle is called radius of a circle. So here, this distance, we call it radius. The fixed distance from center to any point on a circle is called radius. Symbolically, we use small letter r to indicate radius. So again, we have another terminology here. The other term is here. It's a chord. Chord we say this one is the radius, this one is center of the circle. So chord is a line segment. It is a line segment whose endpoints are on the circle. So here, if you take this line segment, as you can see, this line segment, its endpoints are on a circle. So any line segment whose endpoints on a circle is called a chord. So here, you can say this point A, this B. AB is a chord. So AB in the picture, AB is a chord. Okay, now let's see another terminology. Diameter of circle. we use symbol D for diameter, small d. What's diameter? Here, diameter is a chord that passes through the center of the circle. A chord that passes through the center of the circle, we call it this is a diameter. CD is a diameter. So diameter is a chord that passes through the center of the circle. As you can see here, CD is a diameter. So here CD is a diameter. And as you can see, this diameter is the longest chord of a circle. It's the longest chord. So diameter is the longest chord of the circle. Again, you can relate the diameter of a circle with the radius. Look here, the distance from center of a circle to any point on a circle, we say it is radius. Again, this part is also a radius. So this diameter is twice of radius. Therefore, here diameter is twice of radius. Diameter is twice of radius. So in short, we can write this form. D is twice of r. Diameter is twice of radius. Now, let's see another terminology here, circumference of a circle. Now here, circumference of a circle is the length around, the total length around a circle, or the path length around the circle is called circumference of a circle. So here, the total, the path length around a circle is called circumference. The circumference of a circle. So we can use letter C to symbolically denote the circumference. So as we said, circumference is the path length around a circle. Now we'll proceed to how do we calculate the circumference of a circle. Let's proceed to that. Calculating circumference of a circle. Calculating circumference of a circle. Circumference of a circle. Now, to calculate the circumference of a circle, you can try this activity in your home. Suppose take a circle made of a string or a rope. Here you have one circle, and you can make another bigger circle using another string. So if you do this, you'll get some number. Let's see that. Look here, measure first the diameter of this circle made of a string or a rope. Again, here you can measure the diameter of this circles, which is made of a rope. You can try this activity in your home. And then what you do is, so just here break the rope at this point and stretch it. So when you stretch, you may find this length. And this length is, as we said earlier, it is the path length around the circle. So it is a circumference. You can measure the circumference. So the next step, you do this one. You take the ratio of circumference to diameter. You'll get a number. You will have circumference, you measured it, and you have diameter. So when you divide these two, you will get a number which is near to this one, 3.14, near to this. Again, if you take a bigger, this one, this circle, if you cut this rope and stretch it, you will have the circumference of this circle, and you have the diameter here, you measured it. So if you take the ratio of these two, the ratio of circumference to diameter, you will have a number near to this one again, the same. So if you take any different circle, the ratio of circumference to diameter is constant, and that constant is near to 3.14, or sometimes we may approximate it to 22/7. And this constant is denoted by the symbol, this pi. Therefore, here we can generalize this concept in this form. The ratio of circumference to diameter of any circle gives you a constant pi. And we said pi is near to 3.14 or 22/7. Therefore, from this, you have this equation. Just by applying cross multiplication, circumference is equal to this pi times diameter. So you can easily calculate the circumference of a circle using this equation, pi times diameter. Or you may use this equation. So here, circumference is equal to this pi times, as we said earlier, diameter is twice of radius. So here, pi times 2 of r. So we can use this equation, 2 pi times radius. So circumference of a circle can be evaluated using this equation, 2 pi times radius, or using this equation, pi times diameter. And pi is approximately equal to, it is 3.14, or we can use approximate value of pi to be, it is 22/7 or 3.14. So this is it. Now we'll see example for this concept. Let's proceed to the example. Example 1. Example 1. Calculate the circumference of a circle whose diameter is this 10 centimeter long. Here you can use pi to be 3.14. So how do we calculate the circumference of this circle? Let's see the answer together. Here, solution. The diameter of the circle is given. The diameter is 10 centimeter. We are asked to calculate the circumference of the circle. So how do we calculate the circumference? As we derived the formula earlier, circumference is equal to this, simply the product of pi and diameter. Therefore, here we can use pi 3.14. Here it is 3.14 times 3.14 times the diameter is 10 centimeter. So the product of these two gives us this 31.4 centimeter will be the circumference of the circle. Now let's proceed to second example. Example 2. Example 2. Calculate the circumference of a circle whose radius is 7 meter long. Its radius 7 meter long. Use pi in this case. Use pi to be 22/7. Please students, try this question. I will give you 20 seconds for this. Students, have you tried the question? Very good. Now we'll see the answer together. Okay, here the radius is given. The radius of the circle is given to be 7 meter, and we are asked to find the circumference. So how do we calculate circumference? We have already drawn two equations. You can apply this equation. Circumference is equal to pi times diameter, or circumference is equal to 2 pi times radius. In this case, we can use this equation since the radius is given. So circumference is equal to 2 times pi times radius. So this is equal to 2 times pi is given to be here 22/7. So here this is 22/7 times the radius is given to it is 7 meter. Therefore here 7 cancel out. You will have 2 times 22 is 44. Therefore the circumference of this circle is 44 meter. That's it. Now let's proceed to one additional example. Example 3. A piece of land has a semicircular shape as shown below. Here, the piece of land has a semicircular shape like this, and this distance is given to be 200 meter. So the question is, what is the perimeter of this region? Calculate the perimeter of the given region. Perimeter of the region. Okay, let's see this question together. Here, just we are asked to find the perimeter of this region. Perimeter means the total path length is around the given region. Here, as you can see, you have a semicircle. It's a half of a circumference. Again, you have this region, this length, I mean. So, let's assume this point to be A and this point to B. And the perimeter of this region, perimeter of this region, is equal to the length is AB plus this one, the arc BA, which is half of a semicircle, half of a circle I mean, plus BA. BA is this semicircle, arc BA. Now, so here, the length is AB, as you can see, it is 200 meter. So 200 meter plus BA, this BA is, it is a circumference which is half of a circle. So you know that circumference of a full circle is this 2 pi times radius, or circumference pi times diameter. But half of a circle, this equation becomes half of the circumference of a full circle. Therefore, here we use this equation to calculate this length or half circumference. So here BA is equal to this half of pi times the diameter. Therefore, this will be equal to this 200 meter plus half of, let's use pi to be 3.14 times diameter. In this case, this one is a diameter. Since it is a semicircle, this length will be diameter. So 200 meter. Therefore, this will be equal to this 200 meter plus, just I can divide these two by 2, it's 1 by 2, it is 100. 100 times 3.14 gives us 340 meter. So adding these two, you will have 540 meter will be the perimeter of this region. So now we can proceed to how to calculate area of a given circle. So let's proceed to that. Area of a circle. Okay. To calculate area of a circle, let's just try the following activity. Look, if we have this circle and assume this one be center, let's divide this circle into pieces. Let's divide it. Look, this one, we can divide this into so many parts. Let's divide into 8 equal parts. Okay, now let's give a name for these pieces. The first piece, second, third, fourth, fifth, sixth, seventh, and eighth. Now, let's take out each piece and arrange in the following form. Look, this one, let's take the first piece, 1. You will have such a form. Let's take piece 1 to be this form. And let's just put piece 8 upward in this form. This will be piece 8. Again, let's put the second here. Here, this to be second piece. And just put piece 7 to this part. Let's continue to the third piece. Let's put third piece here. Third piece. Okay, third piece with 6 piece upward in this form. Okay, this one is 6. And the fourth piece, let's put it here. And this one, the fourth piece. And let's take the fifth piece here. Okay, so we just cut this one into pieces and we form this pattern. So from this, you can see one thing. Look, this part, this curved part, 1, 2, 3, 4. This curved part is equivalent to this one, 1, 2, 3, 4. So this upper curved part is equivalent to this length, which is half of the circumference. Therefore, this length is half of a circumference. We know that circumference is given by 2 pi r. Half of a circumference it is 2 pi r over 2. It is pi r. So this length is pi r. And this one, as you can see, this also is pi r. The lower part is also this pi r. And this length is a radius. So if you divide this circle into so many pieces, you will have such picture, which is near to a rectangle. You will arrive, if you just divide the piece into so many parts, you will have a rectangle whose length is this length is pi r and radius is this one. So you will have this circle, by dividing into so many pieces, will be converted into a rectangle of the form length pi r with radius. So we can calculate the area of this, which is equivalent to the area of circle. Therefore, here, the area of circle will be equal to the base is pi r, this one is pi r, and the height is radius. So area of a circle is given by the equation pi r squared. So this is the equation we use to calculate area of a circle. Even we can rewrite this equation in using a diameter. How? Look, this one. Area is equal to pi times, we know that radius is half of diameter, d over 2. So I can write this d over 2, the whole squared. So this will be equal to this pi times, when you square this, you have diameter squared. 2 squared is 4. We can use this equation. Area is equal to pi radius squared or pi d squared over 4. So we can use this equation to calculate area of a given circle. Now, let's proceed to example. Example 1. Calculate the area of a circle. The area of a circle whose radius is 2 centimeters long. Okay, now let's see this together. Here, we are asked to calculate the area of the given circle, and the radius is given to be, here it is, 2 centimeters. Here, use pi to be this 3.14. So, to calculate the area, we can use this equation. Area of a circle is given by pi times radius squared. So this is equal to this. We can use pi 3.14 times radius is 2 centimeters, 2 centimeters squared. Therefore, here you have 3.14 times square this, you will have 4 centimeters squared. So let's multiply these two. Multiply 3.14 by 4. 4 times 4 is this, 16. 4 times 1 is this 4, plus 1 is 5. 4 times 3 is this, 12. Therefore, after decimal we have 2. You have this one, it is 12.56 centimeters square will be the area of the circle. Now, let's proceed to second example. This question will be just you'll try it by yourself. Example 2. Example 2. Calculate the area of a circle whose diameter is 20 centimeter long. Please, students, try this question. I will give you 20 seconds for this. Students, have you tried the question? Good. Now let's see the answer together. Here, we are asked to calculate the area of the circle. And the diameter is given. The diameter of the circle is this, 20 centimeter. So, we can use either of this equation. By the way, from this, you can take the radius to be this. Radius is this, half of the diameter. So the radius is this, 10 centimeter. So to calculate the area, you can use either of this equation. Area, pi r squared, or you can use this one. Pi diameter squared over 4. You can use either of the two. But I prefer this one to use, area pi r squared. So let's calculate this. Area is equal to this, pi times radius squared. Pi is, let's take pi to be 3.14. Let's use pi to be this 3.14. So here, 3.14 times radius here it is 10 centimeter. So square it, 10 centimeter. Squared, you have this one, 3.14 times 10 squared is this, 100. Therefore, it is 100 centimeter squared. When you take these two, when you multiply these two, you have 314 centimeter square will be the area of the given circle. Now, let's see one last example. Example 3. In the following figure, calculate the area of shaded region. In the following figure, calculate the area of the shaded region Okay, here you have two circles. So the radius of the smaller circle is this 4 meter, and the radius of the bigger circle, let's use a capital R. This will be this 6 meter. And you are asked to calculate the area of this shaded region. This one. It is a shaded region. We are asked to calculate the area of this shaded region. How do we calculate the area of this shaded region? Let's try this question together. Here, to calculate the area of the shaded region, what you do is simply you subtract the area of this smaller triangle from the bigger, the area of the bigger. So area of shaded region, area of shaded, this will be equal to area of big circle minus area of small circle. Area of small circle. Okay. So this will be equal to the area of big circle. We can use this equation, pi times radius square. We use capital letter here for radius of big circle, pi r squared, minus area of a small circle. We use a small letter r here, so the area of the small circle is pi r square. Therefore, this will be equal to this pi times the radius of the bigger circle is 6 meters squared, minus pi times the radius of a smaller circle is this 4 meters squared. Therefore, this will be the 36 square meter times pi, 36 pi square meter minus this one is 4 square 16 times pi, 16 pi square meter. Therefore, when you subtract this, you will have 20. 36 pi minus 16 pi is 20 pi square meter. Just let's leave the answer in terms of pi. We can leave the answer in this form also. So the area of the shaded region will be 20 pi square meter. That's it. So this is all about today's lesson. I'll give you exercise for you to try it at home. Exercise 1. Calculate the circumference of a circle. Calculate circumference. Circumference of a circle. A circle whose diameter is 40 meters long. Second question. Calculate the perimeter of the following semicircular region. Calculate the perimeter of the following semicircular region. The following semicircular here the semicircle is given, this one, and this length is given to be 600 meters. So you are asked to find the perimeter of the circular region. Okay. One last question. Calculate the area of the shaded region given below. Calculate the area of the shaded region given below. Given below. Here you have two circles, the smaller and the bigger circle, and here the radius of the smaller circle is given to be 8 meters, and the radius of the bigger circle is given to be here 10 meters, and the shaded region is this one. So you are asked to calculate the area of the shaded region. That's it. This is all about. So I'll see you in the next section. Until then, goodbye.